Percent composition is a math formula, basically meaning it's the percentage of each element's mass within a given compound. So there are two ways to write the formula. Basically, the total mass of the element divided by the molar mass of the compound, or in a simpler way, it's the part divided by the whole, and then we want a percent, so we're going to multiply by 100. So I'm going to do an example for you. Okay, so the example says find the percent composition of the compound aluminum bromide. Okay, so here we need to find out the total mass of aluminum. So we have 1 aluminum in that compound times the mass of aluminum. Aluminum is over here, it's 26.98. So 1 times 26.98 gives me 26.98. Okay, now the total mass of bromine. So if you look at the compound here, we have how many bromines? We have 3. So 3 times, and we have to find the mass of bromine, which is here, 79.9. 79.9 is equal to, so on your calculator, 3 times 79.9 is 239.7. Now, if we add this up, then we get the total mass of the entire compound. So if you type it into your calculator, 26.98 plus 239.7, then you are going to get, hopefully, 266.68 grams. So that is of the entire compound of aluminum bromide. So now that we have these pieces of information, the question is, how do we find percent composition? Pretty easy. So let's start out with aluminum. So aluminum is here, 26.98, okay? And then we have the total, which is down here. So what I'm going to do is I'm going to write 26.98 divided by the total. The total was 266.68. I need to multiply by 100 to get a percent. So go ahead and do that on your calculator. 26.98 divided by 266.68 times 100 should give us 10.12% aluminum. All right, then now let's do bromine. Bromine is a lot larger number here, so I'm going to just color this blue here. So 239.7 is what we're going to write down. So 239.7 divided by the total. The total is the same number as before, 266.68. We're going to multiply it by 100 to get a percent. So go ahead and do that on your calculator. 239.7 divided by 266.68 times 100 gets you a whopping 89.88% bromine. So remember, your two percentages here should always add up to what number? Good, it should add up to 100. If you have 3 elements, your 3 percentages will add up to 100, but all your percentages should always add up to 100. But what we can see here is that in this compound aluminum bromide, majority of the mass comes from bromine. Okay, so now you should be able to do the 3 practice problems on your own and check it with the teacher. When you're ready to move on, then we can go to empirical formula. Okay, empirical formula is basically a smallest whole number ratio. It's a ratio. It's not a real compound, okay? When you see the word molecular, this is the real compound. Empirical is what we call the simplified ratio. So they're not real. It's just a simplified. So basically, how can we go from a real to a simplified ratio? Well, we have to take your real compound, look at the numbers, and see if we can reduce them. So if you have a 6, 12, and a 6, we can simplify by dividing each number by 6. So 6 divided by 6 gives you 1. 12 divided by 6 gets you 2. 6 divided by 6 gets you 1. Okay, so for example, if you have a 4 and a 10, what number can we divide both of them by? We can divide both by 2. So 4 divided by 2 becomes 2. 10 divided by 2 becomes 5. So now we have the empirical formula. What about C9H3, O3, and 12? What number can we divide all these numbers by? 9, 3, 3, 12, so we can simplify it. We can divide all of them by 3. So then 9 divided by 3 becomes 3. 3 divided by 3 becomes 1. 3 divided by 3 becomes 1. And 12 divided by 3 becomes 4. That's how you get your simplified empirical formula. Now, what about this? NaCl. You have one of each. So you can't really simplify it. It's already simplified. How convenient. What about B4H8? All right. You can divide both of these numbers by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Now a common mistake on this one is people will try to divide it by 2. If you divide it by 2, then it becomes B2H4, and then you can still simplify it to that. Okay, so if you notice that you didn't reach it all the way, then you do need to simplify it more. Now the last thing I need to teach you is how to go backwards. So remember, the real compound formula is called the molecular formula, which is the title here, so it's a little bit redundant here. Okay, sometimes the empirical and the molecular formula can be the same. Okay, so earlier we saw that NaCl and NaCl are the same exact thing, so it can happen. But here are the steps to go from an empirical to a molecular. It's 4 steps, okay? So here's the example. What is the molecular formula? So it wants the real formula. What is the real formula if it has an empirical formula? So it has the empirical formula here of H2O and a molecular mass of 54 grams. Okay, so here are some key hints here. The very first step says to take the empirical formula and find its mass. Well, the empirical formula is H2O, according to our data here. So the mass of H2O, so 2 hydrogens and 1 oxygen. So we have 2 hydrogens, 1 oxygen. So if you calculate it on your calculator, it's like 16 plus 2-ish. You are going to get 18.016 grams. That is step 1. Take your empirical formula, find the mass. Then step 2 says take the molecular mass and divide it by the empirical mass. Now let me just say here that the molecular mass can also be called the molar mass or just the mass. Okay? So basically we're going to take that number, 54, and we're going to divide it by the number earlier, 18.016. So it should always be a big number divided by a small number. Okay, so when we do this, we get an answer. It should be close to a whole number. Really, really, really close. If it's not close, then you probably did something wrong here. So the close whole number is 3. Okay? You take that whole number, 3, and you're going to multiply it by the empirical formula. We know that the empirical formula was H2O. So here, we're going to multiply the coefficients to find the real formula. So we're basically going backwards. So now, this becomes H6O3. H6O3 is officially our real formula. Remember, we simplified it by dividing, so we're essentially going backwards, so we're multiplying. 3 times H2O is H6O3. That is the real formula. There are 3 practice problems on the next page that you should be able to do by following these 4 steps. So follow the 4 steps and see and get them checked by the teacher.